All right, hello. Welcome to class. March 6th, Monday. So a few things we're going to start off talking about the AP test and our test. So every did I say March? April 6th. Yeah, months, things, whatever. So, test. If you know someone who hasn't taken the test, get them to take the test. If you have anyone's numbers, go through and make sure they actually took the test. I still have about 11 people who haven't taken that. Get those people to go and take those so I can put out a key and you can look at that. The test grade was just curved, so look at the grade on Skyward for the actual curved grade. All right, AP test. I'm sure you've heard a lot. It's been pushed back a week. It's going to be May 14th. I'm sure most of you are still in Texas, so every single one person around the world is going to take this at the same time. So we're going to be taking this at 3 p.m. If for whatever reason you're in another state, you're going to take the test at this time. All right. So the AP test, it's all going to be at the same time. We're only going to have two different questions. All right. So we're going to have one 25-minute question, a long QQT type question, qualitative quantitative translation. We've done these questions all the time, so don't let the name kind of mess you up. It's just qualitative is what will happen if this happens, or which of these is bigger. Explain. Quantitative, then it says go through and actually do the math to get a number or a mathematical expression. And then translation is just saying, well, if I change this, how does that change? If I change radius, if I increase radius, will it roll faster or slower? Things like that. So we've done a lot of these. You'll have 25 minutes to work on this. It sounds like you'll be able to work on this either typing it in on a computer or writing this out on a piece of paper. You'll go through. Once the 25 minutes are done, the question is going to lock and you're going to have to upload your response. So you'll have 5 minutes to upload your response after that, and you can't look back at this question. All right. And then you'll have a second question, which is a paragraph length response. So again, we've done a lot of these also. This will be 15 minutes afterwards, and this will pop up on the screen. You'll go through, you'll work on it for 15 minutes, and then at the end of that, the question will disappear, and you'll also have 5 minutes to upload. So try your best. I know there's possibilities for if you have technical issues, you're going to have to put in a request to take alternate tests later, and they're going to manually review whether or not to let you do that. All right. So this is on Google Classroom. Go through, read this. Obviously, it's going to be open book, open note. They can't stop you from doing this. Again, I'm not going to suggest you just have your textbook up and internet up. You're going to run out of time if you're just blindly looking for things. What I would suggest is you kind of make your own cheat sheet. I'm not going to create one for you because if you go through and if I create it and you use my cheat sheet and use the exact wordings I do, you're going to get caught for plagiarism. So I'm not going to give you a cheat sheet, but I would suggest you do that. Like the things you have written on your formula chart, go through, look through old notes, look through old problems we've done, look through all these AP questions that we're doing because we're doing actual AP test questions, figure out the important things that they have on there. Um, so yeah, it sounds like everyone's taking the test at the same time, and so they are making a big deal about security. Um, if they have any sort of plagiarism, they're just going to fail you immediately, and there might be consequences like failing other tests or taking out the scores on all of them. And they don't care if you're copying or helping someone copy, they're going to give everyone just remove the scores and you pretty much get a zero. So that's one way. The other way they're going to detect plagiarism is it sounds like they're actually going to send us your responses. So it sounds like I'm going to get all of your responses. And if I see someone who like normally gets like a 20 something on a test and then they magically have perfect responses, I am going to report that to College Board. So I'm not going to lie for you and be like, oh yeah, this student always does well, because that's not fair to all of the other students here that aren't cheating. So I am actually going to be part of the plagiarism detection, and I am actually taking that very seriously. Um, that said, it sounds like there's a possibility if they send us this back and I get this back, I'm probably just going to use this as your final exam grade. So yeah, so there's a possibility this will just be your final exam. So someone, Tan was asking about exemptions. It sounds like that's probably what I'm going to use. If I get this back, I'm just going to use that as your final exam grade. All right. Don't copy, obviously, open note, but even when you write something from your notes, don't just copy the sentence directly. That's still considered plagiarism. I would suggest you come up and write your own kind of cheat sheet, like 1 or 2 pages, like a page front and back of every single concept and different equations that are important for that. I'm not going to give you one because that would make it too easy for it to just be plagiarized. Any questions about the AP test or things like that? All right, so it doesn't look like there's questions on that directly. Just feel free to keep asking those. If a question comes up, just ask me next class. Ask me on Wednesday. All right, so if that's done, and they'll post kind of what it's going to look like on that, so you'll be able to look at that. I think in the middle of, like, towards the end of April, they're going to actually like put up like little fake things that will be like the AP test where you can go and log in and make sure all of that works. So that should happen. All right, so now let's look at our classwork. Again, like all of our other classes, pretty much until the end of the year, we're going to be doing this, just going through AP test questions. Obviously, we're going to run out, and I'm just going to have other AP test questions. I don't think I'm going to do a mock. I think it's just going to be like this. That's just going to be too much work to try to figure all of that out. So we're going to be going through old AP test questions. This is pretty much your mock. This is exactly like what's going to happen on the AP test. Notice we have a 25-minute question and a 13-minute question. This is pretty much exactly about what I expect your AP test to be like. These 2 questions you're seeing today. So use this as your mock test. Again, go through, try to solve this. Don't try to... Yeah, what are you going to do with your textbooks? Yeah, I have no idea what's happening with your textbooks. It's probably just going to turn it in next year. So I have no idea. So try to go through, work on these. Don't work with other people when you work through these questions. Don't try to cheat. Don't look at the key. Again, I'm not grading your original work. So don't worry about your original question. As long as you attempt it, and I see you've written things for each one, and I can tell you've worked to the best of your own ability, then you're fine. So you'll work through it. And then the thing I am going to grade is you're going to grade yourself based on the rubric I have posted. Try to grade yourself harshly. And then you're going to go through and write a perfect response after the fact. So the things I'm going to check, you put a solid attempt for your first try. The second thing I'm going to check is that you graded yourself correctly according to the rubric. And then the third thing I'm going to check, that any question you didn't get full points for, you redid that question that in a way that would get you all the points from the rubric. All right? Hopefully that's kind of clear. So when you go through it, try to take this seriously, 25 minutes. So set a timer, work on this for 25 minutes with the resources you're allowed. You can have your notes out. You can have your formula chart out. You can have your book out, things like that. Yeah. So we have this question. This is really similar to one we've done in class. So we have a block initially at position x equals 0. So it starts off at this position right here. In contact. Now, this right here, in contact with. We kind of went through that. But what does in contact with the spring mean? I really don't like this wording for them to say it. If something's in contact with something, is it attached to it? Don't think anyone's answering. But yeah, in contact with doesn't mean attached, doesn't mean stuck to. In contact with means they're just touching. So the block is just touching the spring, not attached to the spring, all right? Really kind of subtle how they chose to word that, and I dislike it, but it's true. It's in contact with an uncompressed spring. So uncompressed means our block is at equilibrium right here, right? So here, we're at equilibrium. And by the way, if you're in this video after the fact, you should work on the question before you listen to me, right? So work on the question before listening to me for 25 minutes, then come back and watch this. So we have an uncompressed spring at position x equals 0. So that's saying this is our equilibrium position, right? So we have equilibrium right here. You probably want to write that on your picture, like EQ for equilibrium. All right, the block is pushed back along a frictionless surface, so no friction from here to here. It's pushed back to position x equals negative d from that equilibrium position. As shown above, compressing the spring by an amount, so it has a magnitude of displacement of d. The block is then released. At x equals 0, the block enters a rough part of the track. So rough, so it enters a part with friction. And it eventually comes to rest at a position x equals 3d. Coefficient of friction between the block and the track is mu. And then again, because the block is just in contact with the spring and not attached to the spring, that means the block is going to leave the spring right here. Questions on that setup? Or wording or anything? All right. And again, I am posting this, so if I go kind of fast or something, feel free to look at the recording after the fact and kind of slow it down and pause and look through it and really analyze what I say. That's going to be the best way to get things out of this. So here it wants us to sketch. So again, sketch, not graph. So I don't need exact points on here. We want our kinetic energy, potential energy of the block spring system along the path from negative d to 3d. Now, again, on your test that you're going to be taking on here, you are probably, a lot of you are going to be writing this on paper. If you have a sketch, please just use a straight edge. So draw things with the straight edge. Look, I don't draw well, and I was able to make this nice looking graph right here. Let's make sure we actually label things, energy and position. That would suck if you didn't label these and they gave you 0 points because they didn't know what graph they were looking at. So we label our graphs. All right, so kinetic energy and potential energy. So let's start with kinetic energy. Here, how fast are we going at position negative d? Zero. It used the word released. I kind of don't like that so much, but they say released, which is kind of implying it starts at rest. So we start with no kinetic energy. Let's make sure to actually label this. We go through, where are we going to reach the most kinetic energy? Can you print the AP test out? Probably not. I don't think you're going to allow you to print it out. So at x equals 0, this is our equilibrium position, which means maximum speed, which means maximum kinetic energy. So we have a real high kinetic energy here. And then we hit a friction surface. So what happens at position 3D? All right, so then we slide to a stop. We stop at position 3D, so our kinetic energy equals 0 joules. So we end up back down here. Now we have to kind of connect the dots. I'm going to draw my spring potential energy first. So let's look, when I pull it back from equilibrium to here, what's my spring potential energy? Big or small? So big, this is our maximum spring potential energy because we have our maximum displacement from equilibrium. So we have a lot of spring potential energy. We get to equilibrium, our displacement is 0 because our displacement from equilibrium is 0 if we're at equilibrium. So we have no spring potential energy. And it stays 0. We leave the spring because, again, the mass is just in contact with the spring, not connected to the spring. So we leave the spring, so we have no spring potential energy here, 0 joules. So we start with a lot, and again, it's important that we have the same amount of spring potential energy as kinetic energy we get, because right here we have no friction. So negative d to 0, no friction, so no loss of mechanical energy. So my spring potential energy is here. It goes to 0 at equilibrium. We leave our spring, so our spring potential energy stays 0. Let's make sure we draw this in an obvious way. So our spring potential energy stays 0. Now, how do we get from here to here? What equation relates spring potential energy to position? Spring potential energy is 1/2 spring constant times position squared. What shape is that going to be? X squared. We have X on our axis. So energy versus X squared, we have quadratic. So we expect to see a parabola. And again, it's X on my x-axis, X squared. Parabola. All right, so our total mechanical energy from here to here is conserved, right? No friction, so total mechanical energy conserved. So from here to here, no force of friction, so we have total mechanical energy conserved. By the way, how much of this do you actually have to write for the points on your graph? Does it say to explain? No, so yeah, you don't need to write any of these for points on the graph. This is just the reasoning behind my graph. So you don't have to write these. It would be good to write this somewhere, but you don't have to actually write this on the test to explain it, unless it says explain it. They just said sketch the graphs. So no force of friction, total mechanical energy is conserved, but then we hit a part where force of friction is not 0, and therefore mechanical energy is going to decrease. All right, so total mechanical energy is conserved between here because I have no friction. So I lose spring energy fast, so I gain kinetic energy fast. Lose spring energy slowly, so I gain kinetic energy slowly. Going to look like this. And then I have to connect my kinetic energy from here to here. Well, I'm dealing with work is going to be force of friction times distance. Force of friction, we've done this a lot, is coefficient of friction times mass times acceleration due to gravity times distance. So I have a constant force of friction, which means I'm going to have a constant slope. And particularly, I'm going to have a negative slope because it's negative work done. But yeah, friction, all that depends on is the normal force, right? Normal force and coefficient of friction, force of friction is the coefficient of friction times normal force, as long as we're sliding. So normal force is just going to equal the weight. That's staying the same. Coefficient of friction isn't changing. So we have a constant frictional force. So I'm taking away energy at a constant rate, which is why we have a constant negative slope. All right, so let's look at our rubric. So again, you're going to work through this and then grade yourself after the fact. Let's see how they actually said this. So sketching either curve, either energy curve with a reasonably correct shape between negative d and 0, with 0 and maximum values at the correct location. So if you got either of these correct, it looks good. They just had U. If you wrote UG, I think I would take off points for all of the spring energy ones. just being on the harsh side. So if you had either picture that looked reasonably correct, so let's say you drew your potential energy well, but your kinetic energy was a straight line, you still get that point. For sketching two curves from negative d to 0 with correct shapes and values such that the total energy is constant. Now, even if the curves are incorrect, so if you drew these in a way where your total energy stayed constant, and they really should say total mechanical energy stays constant. So how you would do that is, let's say you had from here to here, let's say you had a graph like that, like that. I would say that gets the point. I would say that's good. Because lines are still technically curves without curve, right? That was actually getting points for this. Or if you did the incorrect shapes, like let's say you did something like this, that still gets you that second point. They're the incorrect shapes, but your total mechanical energy is conserved. All right? Now, the third point I think is the silliest point to miss. You have to sketch potential energy as 0 from point 0 to 3D. So you have to sketch this 0 right here. So if you didn't draw your 0 in, you didn't get that point. And if you drew it in a way where you can't tell you drew something, you don't get the point. And then the last point is sketching kinetic energy as a linear function, maximum value at 0, and you're slowly losing energy as your position increases until you get to 0 here. So you have to start, kinetic energy has to be maximum at equilibrium, it has to reach 0 at point 3D, and it has to be linear. Now again, linear, hopefully you have a straight edge at home, a ruler, or just anything that's relatively straight that you could use. If you don't, just try to draw it as straight as possible, and then right next to it, this is a straight line. Questions on the points for this one. So 4 points, kind of a lot for relatively straightforward graph. So now we're on to B. All right. So now the spring is compressed twice as much. So again, this is qualitative quantitative translation. So translation, we're changing something. So twice as much to position x equals 2D. And again, like you asked Tan, I think that was Tan asking it, that's really talking about magnitude of displacement. They're just not as deliberate as I am. Honestly, most of the questions aren't going to be as deliberate with their magnitude bars. That's more something you're going to see in Physics C and later. So they do mean it's compressed to a position negative 2D, and the displacement has a magnitude of 2D. A student is asked to predict whether the final position of the block will be twice as far at x equals 6D. So if it's compressed twice as much, is it going to go twice as far? The student reasons that since the spring will be compressed twice as much as before, the block will have more energy when it leaves the spring, so it will slide further along the track before stopping at position x equals D. So B1 wants to know what is correct and explain how I got at the correct answer. So the spring is compressed twice as far. What did they say? That's correct. More energy. So more compression means more spring potential energy. Now, again, this is one of those things, like I was saying, when you're taking your test, if you're writing this on paper or in a Word document or something, you have all the space in the world to write. But you pretty much never have a reason to write more than 3 or 4 sentences. So don't sit here writing a giant paragraph or like an entire essay. Just really try to keep yourself to like at most 3 or 4 sentences. So more compression means more spring potential energy. We could just give our equation. Spring potential energy is 1/2 spring constant times that displacement from equilibrium squared. And so I see from my equation, more compression means more spring potential energy. And then we could write that next to that. And then, yeah, you can put some words explaining it. Do we have to correct the parts that we got fully correct or just the parts we got? Yeah, so if you got it fully correct, if you got all points, you don't need to correct it. But if you missed 1 point, I want you to correct it. So fully correct, you do not need to correct. And then if it's someone I'm used to seeing fully correct answers from, I'm not going to question it. If it's someone who's like never gotten a fully correct point on a test before, I'm going to be extremely suspicious if you got fully correct, and I'm just not going to count it as full credit. I'm not going to say who that is because I'm not going to try to call anyone out. All right, so that's one thing that's correct. What else is correct? We have more energy. I'm not trying to throw it on any direct people, but there's another thing that's correct. So that means more energy. So the block will slide further. So not sure about displacement. Yeah, it's not going to be exactly 60. So that's going to be correct. And we can just say, well, if the block has more energy, more work needed to stop the block. But the force of friction does not change. Which means that force of friction, not force of friction, work done by friction is going to go up is equal to the force of friction times distance. That's constant, which means it's going to have to slide a greater distance. So again, you should not be writing more than 3 sentences for pretty much any of these. And then it doesn't say actually correct them. So it says explain how I got there. So it's not correct them, just explain why I think those are correct. And then 2, what is incorrect? Well, we see spring energy as 1/2 spring constant times displacement squared. Means 2 times the distance gives 4 times as much spring energy. Well, I know work done by friction is going to be force of friction times distance. Well, if I have not changing frictional force is unchanged, right? Because that frictional force just depends on the coefficient of friction and normal force, and I'm not changing either of those. So friction is unchanged. That means I have 4 times as much energy, means block will travel 4 times as far. And again, I cannot stress this enough. Do not write more than 3 or 4 sentences. All right, so let's check the key. Each one of these is worth 1 point. Identifying the student is correct that the block will have more energy when it leaves the spring. So that was enough. So as long as you said the block has more energy when it leaves the spring, it would be good to write that equation. And then they're incorrect that the new position is going to be exactly twice as far and does not scale linearly. That could have been as much as you just saying, giving the equations. Spring energy is 1/2 spring constant times position, that displacement from equilibrium squared. So you could just say, oh, that's not a linear increase. I have twice as much compression does not mean twice as much energy, something like that. Or say this is a quadratic relationship. So 1 point for each of those. You didn't even need as much detail as I wrote. All right, keep this going. So use quantitative reasoning. Quantitative, what does quantitative mean? Quantitative is numbers or not numbers? So quantitative means numbers and expressions. And then qualitative something like that, means words and explanations. So quantitative means use numbers and expressions. So use quantitative reasoning, including equations as needed, to develop an expression for the new final position of the block and express your answers in terms of D. All right, so we are going to be using energy. So I like to do total mechanical change. What am I doing? Work is change in energy. So there is friction. So work is going to be change in that total mechanical energy. Now, we have these three spots. So I have spring energy is going to kinetic energy, right? This is at position negative D. This is at our equilibrium position. And then this is all lost to friction as heat. So all my spring energy turns to kinetic energy, right? So I could just look at my spring energy first. So let's kind of look at this. So work is going to be force of friction times distance times cosine, but instead of cosine, it's just negative work. I'm just going to put that as a negative work. So I have final total mechanical energy, kinetic energy final, plus spring potential energy final, minus all of my initials, kinetic energy initial, spring potential energy initial. I'm going to go all the way back here. I'm going to call this my initial and then this my final. And just kind of ignore the kinetic energy in the middle, right? There's no friction here, so I'm not losing energy. So I'm just going to say all my spring energy ends up getting taken away by friction, even though it's more like the kinetic energy is getting taken away, but these two values are equal. All right? So final, my spring energy was lost. Leave the spring. And my kinetic energy is lost. We stop. All right, well, I'm using this as my initial, so it's released from rest, released, which means the only thing I'm left over is this initial spring energy. All right, well, force of friction, what is force of friction equal to? Coefficient of friction times normal force. And again, we are sliding across the surface, slide, so it's not the less than. Our normal force, like you said, mg, our normal force is just exactly equal to our weight because we're on a flat surface. So this is just coefficient of friction times mass times acceleration due to gravity. All right, so I can put this in here. So negative coefficient of friction, mass times acceleration due to gravity times distance, is all equal to negative 1/2 spring constant times that displacement from equilibrium squared. So how far this thing was compressed. So I could go through and do a few things. We're trying to really see how our distance value changes. So let's divide everything over and let's be careful. These are different distances, right? This is how much the spring is compressed. This is how much the block slides. So that's why I'm really careful about calling this delta x instead of just calling it something like d. All right, so let's divide negative mu mg over. So the distance this block slides is going to be spring constant times how far the spring is compressed from equilibrium squared divided by coefficient of friction divided by mass divided by acceleration due to gravity. Now, what's the only thing I change? I mean, I didn't change my spring, so spring constant didn't change. I didn't change coefficient of friction or mass times acceleration due to gravity. Yeah, all I changed was 2d. So my displacement goes up times 2, but this is squared, right? So before, so my original distance, so distance would be k times d, actually it's a capital D squared over mu mg. So this is my original distance. And then my new distance is going to be spring constant times 2d squared over mu mg. 2 squared is just 4 times the spring constant times that distance squared divided by mu mg. Well, this old distance, it slid to a position 3d, right? That's what it says in the problem. It slid to position 3d. Well, 3d is equal to this whole kd squared over mu mg. So this whole thing is equal to this stuff in parentheses. So my new distance traveled is going to be 4 times that old distance traveled, or 12d. And that's quantitative, because I got an expression or a number. Now, I did this with way more work than you need to, right? We could have just gotten to this point, oh, this went up by a factor of 2. Well, 2 squared is 4, so I go 4 times as far. You really didn't need to go through all of this math I went through. I just like reasoning with math. So feel free to not go through all of this I did here. You could have just gotten here. It's compressed twice as far. 2 squared is 4, so it goes 4 times as far. And then you just write, okay, so it goes 4 times as far as before, so 12d. If that's a little bit nicer. You also didn't have to go through all this mess here. You could have just said, oh, I end up with no mechanical energy minus my spring energy I started with. And you didn't even have to do that. There's some other ways around that. Any other questions? Let's look at our key if there's not. So that's 3 points there. So 1 point indicating the final energy of the spring, which becomes the mechanical energy of the block as it reaches the rough track, is 4 times the original energy. A few ways of doing that. I did it mathematically, plugging it in. You could have just gone to the expression and showed 1/2 kx squared, x squared, so 2 times the compression of the spring means 4 times the energy. If you wrote that, you got those points. For indicating frictional force remains the same. This is a really important point. So one way of indicating it is just explicitly writing it out in words. So you could say, oh, frictional force is mu mg, the coefficient of friction, times mass times acceleration due to gravity. You could sit there and say, oh, the frictional force stays the same because the surface don't change, and the mass does not change. Or you could write it how I wrote the arrows in mine. Or you could go through and just do the math 2 different times. Notice how they just did the math 2 different times here. And notice how they put in mu mg, mu mg. That would be quantitative reasoning. So that's implying that they're the same because they wrote the force of friction the same both times. All right. And then the last point, For an equation, for equating the initial energy of the spring to an expression that shows that energy dissipated by friction is proportional to the distance the block slides down the rough track. So they're just saying to get to this equation here. Notice there's 0 points for the correct answer. So right here, no points for the correct answer, just as long as you got to a point where you said work is some value times distance. That's all you needed. So you didn't actually have to get the final answer. Now, one thing that the AP graders have been talking about is because a lot of these questions are probably going to be really conceptual because they want to kind of cut down on your ability to just look things up online. There's probably going to be a lot of concepts, and they really want you to go through and try to solve the question, try to explain it before writing the answer. So you're going to be a lot better served. Don't write the answer at the beginning of the question. If you write the answer at the beginning of the question and you're wrong, it's really easy to just say 0 points. So go through, try to do your reasoning, try to solve things out, try to explain what you know first, and then put your answer at the very end. Then they may have given you points through here, and then they're like, oh, wow, you messed up here, and then, oh, I'm not going to give you the rest of the points. But don't write your answer to the end. You're going to be a lot better off. Go through, say what you know, work through what you know, kind of do that, and then write your answer at the very end. That way they're not kind of biased against you on points. All right. And then this last one, which I think is the most repetitive thing in the world, but whatever, we still need to answer it. Explain how any correct aspects of the student's reasoning identified in part B are expressed by your mathematical relationship in part C. Explain how your relationships in part C correct any incorrect aspect of the student's reasoning identified in part B. Refer to the relationships you wrote in part C, not just the final answer you obtained by manipulating those relationships. So that's not confusing at all. But it's pretty much saying, how did I correct them? So identify the correct things that they saw in B. So notice how they're kind of asking us to restate things. So let's go through and restate it. One thing we can't do, if I go here and I circle something and I draw it down here, that means I don't look at it anymore. Like, let's say I drew this like this with an arrow and I put it down here. How they read that is don't grade this here, only grade that here. So they pretend this doesn't exist in this question and only exists here. So a few ways, you either need to rewrite this again here or you need to reference it. So we can say the spring is compressed more, meaning more spring potential energy, as shown by spring potential energy equals 1/2 K times 2D squared equals 4 times 1/2 spring constant times distance squared. So I can write that. All right, so we have more compression means more energy. And that's from part B. And then we can also say, however, comma, we have 4 times the spring energy. Which results in traveling 4 times as far. To 12D. Something like that. So relating what we saw. Again, try not to go more than just a few lines, a few words. So rubric here. So 1 point, indicating the student is correct that the block has more energy in the second situation, expressed by calculations comparing initial energy of the spring. So yeah, I would say I did that by showing 1/2 kx squared. Well, I compressed it to 2D, so I end up with 4 times the amount of energy. All right, so 1 point for showing that more compression means more spring energy. For indicating the student's correct reasoning that the block will slide further is expressed by an equation that indicates the work done by friction to stop the block in the second situation is some factor greater than the work done by the first situation. I didn't explicitly show that. I guess I should have written the equation there. That's pretty much saying something about writing this expression here. So I could have gone through and written that the final position distance traveled is the spring constant times the displacement from equilibrium squared divided by coefficient of friction, mass times acceleration due to gravity. So that would just be writing that equation saying bigger compression means the block travels a greater distance. And then the last point for indicating the student's incorrect reasoning that energy scales linearly with the spring's compression is corrected by an expression for the initial energy of the spring. That's all just getting at the fact that when I compress this twice as far, I end up with 4 times as much energy. So I compress this twice as far, I got 4 times as much energy, which meant I traveled 4 times as far as opposed to just traveling 2 times as far. All right, so we spent a lot of time on that. Any questions before we go on to the next one? So this video doesn't end up being way too long. All right, so let's go on to this next one. So again, you'll have that 25-minute question. You have 25 minutes to work through it. The question's going to cut off after 25 minutes, and you'll have 5 minutes to upload. And then the upload period is going to cut off, and then it's going to go straight into the next question where you have 15 minutes. All right. They said they will give you like a practice thing where you can go in and see what the AP test will look like sometime towards the end of April. So not, yeah. Do they autocorrect on the AP test? I doubt they're going to autocorrect for you. They might, but they might not. Wait, one question. So I did not use work in C, but in D, I explained that work is used to correct. So no, they never said work. You didn't have to. You talked about energy though, right? So if you talked about energy and you used your spring potential energy and you showed I have 4 times as much spring potential energy, I think you should get that. Because if you're talking about energy, work is just change in energy. So it kind of depends how you wrote it. Also on the AP test, the other thing, I don't know how it's going to look if they're expecting you to write it on a Word document or a piece of paper. I know one thing you can do is write it on a piece of paper and upload the paper. Obviously, that won't be autocorrected. If you use a Word document, that will obviously be autocorrected. But yeah, I don't have enough information on that exact situation yet. All right, so 25 minutes for that, 5 minutes upload, then you have 15 minutes for this next part. So this one's going to be a little bit shorter, and then you'll have 5 minutes to upload after this. Again, please, 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 I know you have all the space in the world to write this because you're going to be putting it on paper or in a document that won't be limited by space, but you never, never, never need more than just 4 sentences. When you fix autocorrect to contain your cheat sheet. Wait, what? What do you mean by that? Oh, so like you just type in something and it just automatically you just type like conservation of energy and it just like pops up in a formula or something. I mean, I guess there's nothing stopping you from using macros like that. Yeah. But yeah, everyone really should be trying to make a cheat sheet. Photomath? What is photomath? I don't know what that is. All right, I'm just going to keep going. If you have questions at the end, I'm going to answer those. I don't want this to end up being too long. All right, so now we're on to this one. So we have a wheel on a ramp going down. So a wooden wheel of mass capital M consisting of a rim with spokes. The spokes are just the things connecting the rim to the center. Um, Rolls down a ramp that makes an angle theta with a horizontal as shown above. The ramp exerts a force of static friction on the wheel so that the wheel rolls down without slipping. Again, static friction means no slipping. All right, so on the diagram below, draw and label the forces, not components, so not X and Y components, things like that, that act on the wheel as it rolls down the ramp, which is indicated by the dashed line. Clearly indicate at which point on the wheel each force is exerted. So I need to draw the force starting where the force is acting and pointing away from that force. And the links of the arrows need not indicate the relative magnitudes of the forces, so that's good. They're not actually grading you based on how long you draw these. All right, so sketch this out. We have this. We have our wheel. We have the spokes going to that wheel. All right, what forces do we have? And I'm actually not going to draw the spokes. Well, we have gravity pulling straight down, force of gravity. Again, you have to write force of gravity or mg or something like that. Normal force. Where does normal force act from? Surface. Normal forces are always dealing with surfaces. So the normal force acts from the surface, and then it's always perpendicular to the surface. So that's going to go up through the center of the circle. Let's make sure we label our normal force. And if we're being really careful, our normal force is less than weight. I know they didn't say we have to do that, but we do have that. All right, where does our frictional force act from? Friction is the force between two surfaces. So where is the frictional force acting from? The surface. So between the wheel and the ramp. Which way is friction? This thing rolls down the ramp. Friction is an opposing force, so friction acts up the ramp, right? So force of friction is acting up the ramp. All right. Now we can get 2 points here. So 1 point for a labeled arrow representing the gravitational force starting at the wheel's center and directed downward. So 1 point, we have gravity, force of gravity, pulling straight down from the center of the mass. All right, gravity always pulls straight down from the center of the mass. That was 1. The second point is a little bit harder to get because we have to get the friction and normal forces acting from the surface. So our normal force has to go perpendicular to the surface up through the center, and then our frictional force is going to be up the ramp. They said we can combine these. That is one thing we could do. We can combine these into one resultant vector that's just the surface forces. I tend not to do that with y'all, though, so we're just going to keep these separated. So we get 2 points for those. All right. This next part, as the wheel rolls down the ramp, which force causes a change in angular velocity of the wheel with respect to its center of mass? Change in angular velocity. What are we talking about? Torque, right? Because change in angular velocity is angular acceleration. So net torque over a moment of inertia. So we're looking for angular acceleration. Well, torque is radius times force times sine of the angle between radius and force. So which one of these provides a torque? Well, let's look at force of gravity. Torque by force of gravity. Well, radius, it acts on the center, so 0 times the weight is 0 Newton meters of torque. Well, that's not doing torque. Let's look at torque caused by our normal force. All right, well, the radius, it is acting a distance from the center, but it's going straight through the center, so times normal force times sine, it's going straight to the center. So it's along the radius, so sine of 0 degrees equals 0 Newton meters. So that just leaves force of friction. So torque caused by force of friction. So it's at radius r from the center times force of friction times sine 90 degrees, right? Perpendicular between the radius and the force. So that's just radius times force of friction. So it is going to be the force of friction. So you would say something like the force of gravity is acting on the center of mass, so that does not cause a torque. Normal force pushes through the center of mass, so that's not causing a torque. So the frictional force is the only force that acts on a point not at the center of mass, not at the center of that rotation, and at an angle that's not towards the center of the circle. So you get that point for saying frictional force. If you wrote the wrong force, you can't earn a point, so you just get nothing. For correctly explaining that friction is the only force that exerts a torque with respect to the wheel center of mass. So causal chain of reasoning about forces. So gravitational force leads to a normal force, acceleration down the ramp. Yeah, so you could talk about it that way. So this is just saying, if you were saying things like the gravity is pulling the thing down the ramp, but friction is the thing causing it to turn, that would be something you could talk about. But yeah, just something talking about gravity acts on the center of mass, so it can't cause a torque. The normal force pushes through the center of mass, so it can't cause a torque. So friction acts at a distance from the center of mass at an angle that's not 0. To get that point. I don't know why I put this down, because we're going to look. Yeah, whatever. All right, and then C, in a second experiment on the same ramp, a block of ice, also mass m, released from rest at the same instant the wheel is released from rest at the same height. The block slides down the ramp with negligible friction. Which object reaches the bottom of the ramp first? Or with greatest speed, I mean. What reaches the bottom first? The wheel, the block, or where they both end up at the same speed? What about B? Oh, I mean, I guess I can write it out, but I would just say friction is the only force acting at a point away from the center of mass. At an angle not toward or away from that center of rotation. Just pretty much getting at, this is the only thing. So gravity doesn't cause a torque because it acts on the center of mass. Normal force doesn't cause a torque because it pushes up through that center this thing is rotating about. 2B, where you drive an expression. Oh, yeah, I did miss 2B. What am I saying? 2B, yeah, I read the wrong thing. Sorry about that. B, so for the ramp angle, the force of friction exerted on the wheel is less than the maximum possible static friction force. Instead, the magnitude of the force of friction, static friction exerted on the wheel is 40% of the magnitude of the force or force component directed opposite to the force of friction. Derive an expression for the linear acceleration of the wheel's center of mass in terms of mass, theta, and physical constants as appropriate. All right, so when we do this, we're going to have to look at our net force. So we're trying to find our acceleration down the ramp. Linear acceleration. So acceleration is net force divided by mass. All right, so a free body diagram. Which part of the gravity acts down the ramp, sine or cosine? So sine slides down the ramp, right? Nor force times cosine of the angle. These two forces are going to be equal. So sine slides down the ramp. So my net force is going to be big minus small. So if we accelerate down the ramp, my weight times sine of the angle is bigger than the friction. So my net force is going to be weight times sine of the angle minus the force of friction divided by mass. But they say the magnitude of the force of static friction is 40% of the magnitude of the force or force component directed opposite to the force of friction. So it's a really weird way of saying it, but they're pretty much saying this force of friction is going to equal 40%, so 0.4 times the component in the opposite direction. So that's going to be 0.4 times the weight times sine of the angle. That's that whole 40%. So my frictional force is 40% of the force down the ramp, which is weight times sine of the angle. So our acceleration is going to be weight is mg times sine of the angle minus 0.4 mass times the acceleration due to gravity times sine of the angle, all divided by mass. 1 minus 0.4. Is 0.6 apparently. Acceleration is 0.6 mass times acceleration due to gravity times sine of the angle divided by mass. Again, mass is going to divide out. So our acceleration is going to be 0.6 times acceleration due to gravity times sine of the angle of the ramp. All right, so looking at this, you get a point expression of the sum of the force components parallel to the ramp. So pretty much saying that net force is the weight sine of the angle minus the frictional force. Then indicating the frictional force is this value explicitly or implicitly. Implicitly would be you just get to 0.6. And correctly solving for the acceleration in terms of the correct variables. So you had to get to this point, and then you had to get to dividing by the mass. So notice that first point wasn't so bad. You just get the net force, and then this last point is like do everything correctly after that point. Which is sometimes how I feel about how they grade. Sometimes there's like, everyone gets a point, and then the other one is like, you need to donate a kidney to earn that point. All right, so let's keep going. If you need to look back at this, you can look back at this, but this video, I don't want this video to be completely too long. All right, so C, so the second experiment, a block of ice without friction slides down, and then the other wheel rolls down. Yeah, that one was worded really weird. I honestly don't like how that one's worded. So yeah, which object reaches the bottom of the ramp with the greatest speed? The block or the wheel? The block. Now it's asking in terms of forces, right? They're asking in terms of forces because acceleration is net force divided by mass. Well, they have the same mass, so the only thing that's going to change is net force. So the block has no force of friction. So that means the net force is just going to be weight times sine of the angle. The wheel has friction, so the net force is going to equal that mg sine of the angle minus force of friction. So that means the block has a bigger net force. Net force of the block is bigger than the net force of the wheel, which means the acceleration of the block is greater than that of the wheel. And in terms of forces. So that means that the block, final speed of the block is going to be greater than the final speed of the wheel. And actually put those into sentences, I would say the block has a bigger net force than the wheel because the wheel has friction opposing it. That means the block accelerates at a greater rate than the wheel. So the block is going to be traveling at a greater speed at the bottom of the ramp. And of course, you only get 1 point. No credit without explanation. So if you just get the answer, no credit. But yeah, so the wheel experiences a counteracting frictional force. So the block has a greater net force and greater acceleration. No, the net force on the block is not 0. Because for the block, we're going to have weight times sine of the angle down the ramp. We have weight times cosine of the angle up the ramp or into the ramp, and then we have our normal force. These two forces are going to balance each other out. So our net force is just going to be the weight times sine of the angle. This is all the way back to the beginning of the year, a ramp without friction. All right, and then the last thing is briefly explain your answer again, now reasoning in terms of energy. All right, so now, does friction make total mechanical energy decrease with the will? Well, let's get into that in a second. So these both start with gravitational potential energy, right? So when we're talking about the block, our gravitational potential energy initial is all turning into kinetic energy final. But when we have our will, our gravitational potential energy is turning into rotational kinetic energy final and translational kinetic energy final, right? Now, when we're talking about friction doing work, work is force times distance, but it's distance that the two surfaces slide. So is this will sliding across the surface? The will is not sliding. So we'll see that each individual point just goes down and touches the surface and then rolls past it. It's not sliding across the surface. So when we're dealing with static friction, there is not going to be work. Now you're going to get to a point later, if you keep doing engineering physics, you'll get to rolling friction. Rolling friction has to deal with, it's called plastic deformation, the thing itself actually bending. When this bends, it causes friction. So inside your car tire, there are frictions when the wheel itself flexes, and that is going to do work. But when we have a perfectly rigid object rolling and not flexing like that without slipping, there will not be any work done by the friction. If that makes sense. Well, I mean, it will do work. Let me rephrase that. The friction is not going to do work converting energy to heat. it will do some work converting some of the energy from potential energy into rotational energy, things like that. All right, so the block, all of the energy is going to making it go sideways, right? All the gravitational potential energy makes the block slide down the ramp. But here, some energy used to make the wheel roll so therefore less energy to move the wheel down the ramp. They both start with the same. They start with the same gravitational potential energy. So all the energy goes to make the block slide. Some of the energy makes the wheel roll, means I have less to make the energy move down the ramp sideways, move translational motion. Same gravitational potential energy, which means the block slides faster. And so let's see what the rubric actually states. So correct explanation in terms of energy conservation. Both object Earth systems lose the same amount of potential energy. So that would be sufficient, either saying they start with the same potential energy because that's implying the energy is going elsewhere. They gain the same amount of kinetic energy, the ice block, but not the wheel. Yeah. So they gain the same amount of kinetic energy, but for the ice block, all of that goes into translational kinetic energy. Again, translational, side to side, making things move sideways. So the block gets a lot of its energy in terms of that sideways kinetic energy. But the wheel has to put some of that into rotational kinetic energy. The rotational kinetic energy means it's not going to move as fast. All right, any last questions on that? So again, one more time, just grade yourself. The only thing I'm going to check is that your original answer was done to the best of your ability, and it's not done way above your level of ability. I don't want to see you have a perfect answer if that's not where you're used to on tests. The things I'm going to grade is how well you grade yourself and that you got a perfect response after the fact. All right. So again, if there's any more questions on this, I can answer those tomorrow in tutorials. This is due. Did I not put a due date on this? It'll be due whatever is stated on here. Yeah, I guess I'll put a due date on it. Yeah, I'll go and change that. It'll probably be due Thursday or something. It's not a whole lot to do. Yeah, we'll make it due Thursday. So again, I want a picture of your original responses. I want a picture of your grading of those responses. And then if you did not get the full points for any of the parts, I need your corrected answers for that. All right, and then make sure you read the AP test information, and then I'll see you again for class on Wednesday.